Welcome to the direct GPS over fiber system installation video created by the engineering experts at HUBER and SUHNER. This video is intended for installation and service personnel who are involved in the planning, installation, operation, and maintenance of HUBER and SUHNER GPS over fiber systems. We recommend reading the complete manual prior to unpacking and installation of the product. This installation video does not replace the timing system design to ensure a proper system operation. In this video, we will cover a variety of topics related to the installation of this product. We will begin with an overview of the direct GPS over fiber system, covering the contents of what is included in the actual system, as well as its features and benefits. Then we will continue with the installation instructions. Finally, we will end the video with common troubleshooting measures, should they be needed. The direct GPS over fiber system consists of multiple parts and pieces, including the direct GPS over fiber TX, otherwise referred to as the antenna, with mounting bracket and screws. The direct GPS over fiber MAC8-1 RX, also known as the MAC8 or receiver, with power supply and adapters. An additional item that is not part of the system but needed for installation is the QODC12 assembly or fiber optic cable assembly. All HUBER and SUHNER products are thoroughly cleaned and sanitized in a factory setting. However, dust and debris may settle during transport. A brief inspection with the connector end face quality inspection scope prior to connector mating can save time later in the installation process. If cleaning of the QODC12 connectors are needed, please refer to the troubleshooting lesson of this video. Here is a basic installation sketch of our direct GPS over fiber system. It consists of an active antenna with an integrated GPS over fiber transmitter that provides the following benefits: reduces the need for multiple GPS antennas, reaches longer distances over fiber optic cabling, hence the name GPS over fiber, eliminates the need for costly remote antenna power infrastructure thanks to a copper-free GPS link that uses fiber optic cabling or power over fiber to distribute both the power and signal. And finally, AC power is not required on the roof, which results in less roof penetrations. The QODC12 fiber optic assembly transmits the GPS signal and power from the antenna to the direct GPS over fiber receiver module, or MAC8. For your safety, you should avoid looking directly into the fiber optic ports or fiber optic connector when the power is on, or when one part of the cable is connected to a module, as invisible laser radiation poses risks of serious eye injury. As an additional safety feature, the direct GPS over fiber system made by HUBER and SUHNER includes an interlock safety feature where the full power of the laser is only transmitted if the QODC12 connector is connected to the receiver and the antenna. The receiver distributes the timing signal to up to 8 GPS receiver systems, such as cellular radio, timing source, or other devices requiring a GPS signal for timing reference. It also provides the status of power and link availability, as well as laser output via LEDs. And finally, it contains a fiber optic output for further signal expansion to different types of expansion modules, resulting in unlimited end devices covered with a single timing input. For more information, please refer to Lesson 6, Option to expand the signal. Lesson 2, Direct GPS over Fiber TX Antenna Installation. In this lesson, we will cover the installation of the Direct GPS over Fiber Integrated TX Antenna Unit. First, mount the antenna bracket to a wall or antenna mast. When locating the antenna, best practice suggests you ensure a clear view to the sky. Then mount the antenna to the mounting bracket using the supplied screws. Remove the protective cap from the fiber optic antenna port. Then, remove the protective cap from the QODC12 fiber connector. And here's a helpful installation tip. The protective caps should be removed right before mating to avoid potential contamination. For your safety, you should avoid looking directly into the fiber optic ports or fiber optic connector when the power is on, or when one part of the cable is connected to a module, as invisible laser radiation poses risks of serious eye injury. When certain the line is powered off, mate the QODC12 fiber connector to the bottom of the antenna. Begin by rotating the connector to align arrows, then push together until an audible click is heard. Then position hands on the boot and gently tug to ensure a secure connection. When finished, connect the protective caps together to protect the connectors from potential contaminants during future use. Finally, using a fiber optic cable clamp, secure the fiber optic cable to the antenna pole, being careful to not use too much force. Too much pressure applied to the cable or bending the cable with a radius of 2 3/4 inches or 70 millimeters or less may potentially affect performance. For specific details, please refer to the installation manual. Lesson 3. Direct GPS-over-Fiber RX MAC 8 installation. In this lesson, we will cover the installation of the direct GPS-over-Fiber receiving unit. Let's begin by mounting the receiver into the cabinet or rack with 4 screws. Then connect the QODC12 fiber connector from the antenna to the fiber optic input port at the rear of the receiver. Begin by removing the protective caps, then bring connectors together. Rotate the connector to align arrows, then push together until an audible click is heard. Position hands on boot and gently tug to ensure a secure connection. Finally, connect the protective caps. When finished mating the QODC12 connector to the receiver, screw dry contact wires to the related status signal contact on the back of the module. Make sure you wire the appropriate port to the appropriate dry contact. Connect the power connector to the 12-volt DC 1.6 amp input port at the rear of the unit. Connect the other end of the power connect or power cable to the DC-DC converter 12-volt DC output 1 connection. You can also use the power outlet with supplied adapter. Connect all RF outputs on the front panel to the corresponding receiver system inputs. When finished, we recommend all RF output ports be terminated. Lesson 4. DC-DC converter installation. In Lesson 4, we will review the DC-DC converter installation. For your safety, it is essential to ensure all power switches of equipment that will be connected to the DC-DC converter in the following steps are turned off. Once confirmed that the power is off, mount the GPS-over-Fiber DC-DC converter to your rack by tightening the 4 screws on the front. Then, install a protective sheath conductor by a closed-loop terminal crimped onto the PE conductor. Finally, secure the PE conductor at the rear of the enclosure. The unit can support 2 units out of our GPS-over-Fiber portfolio. There is no preferred power outlet. Connect the DC-DC converter 12-volt DC out 1 and or 12-volt DC out 2 to a compatible GPS-over-Fiber product, 12-volt DC in, using the included power cable. Disconnect the green connector from 48-volt DC input 1 and 48-volt DC input 2. Connectors are secured by screws, so tools will be necessary. The unit is designed for dual power supply usage for redundancy reasons. If only one single power line is available, the 48-volt DC input 2 connector can stay unconnected. Strip and cut AWG18 conductors in the terminals of the green connectors and tighten with a screwdriver to a torque of 4.42 to 5.3 pounds per inch, or 0.5 to 0.6 Newton meters. Connect the conductor to negative 48 volts DC circuit with a minimum current rating of 10A. Ensure positive and negative terminals are not inverted. Connect green connectors to the direct GPS-over-Fiber DC-DC converter. Once finished, your DC-DC converter installation is now complete. Lesson 5. Power on all units. In this lesson, we will power up the system. First, ensure all modules are connected to a power source unit like a DC-DC converter or power outlet. Once the receiver power switch is on, the unit will send a lower power signal to the outdoor unit in order to identify its presence. This low-level signal will also validate that the connections are compliant with the safety specifications of the system. The automatic test and reboot function assures an automatic restart of the direct GPS-over-Fiber system as soon as power is back on after a blackout at the facility in which it was installed. Check if the fuse is functional, and if not, replace with a 2.5 amp slow-blow 250-volt fuse. Once the safety system has confirmed that all connections are in place, the Link On and Laser On LEDs will turn on. These two LEDs confirm that the link is functional. The system status can also be monitored remotely over the dry contacts connected to the status signal ports on the back of the module. If units are not powering on or the LEDs do not turn green, please refer to troubleshooting. Lesson 6. Option to expand the signal. You have finished the basic installation, and now you have several options to expand the signal to various expansion modules. This video will focus on 4 options. With the first option, you can use the FO out port from the receiver to the GPS-over-Fiber 8 16 or 32 port module to expand and convert the fiber optic signals into 32 RF signals at most. With option 2, you can expand the timing signal from the FO out port on the receiver to extend modules with 2 FO output ports and 16 RF outputs. And with the third option, you can use any RF out port from the receiver to the GPS-over-Fiber amplified expansion 16 and 32 port modules to expand the timing signal up to 32 RF ports. The 16 and 32 port modules can be used in combination with all RF out ports in the GPS-over-Fiber portfolio, but keep in mind the lengths limitation of a high-quality RF cable, which is approximately 60 feet or 18 meters. Don't forget to factor in the cable length that is used to connect the extension modules. For a valid length estimation, please contact your system architect or HUBER and SUHNER technical support. The fourth option to expand the signal uses an active optical splitting module, or OSM module. In this option, you can expand the timing signal from 8 FO out ports on the receiver to up to 8 extend modules with an FO in port. It is also possible to cascade the OSM to receive unlimited timing reference signals. Now that you have a better understanding of the options to expand the signal, let's begin preparing the system for expansion. First, connect a low-loss RF cable to your GPS RF receiving system. Then, connect the other end of the RF assembly to the GPS-over-Fiber RX RF outputs. Use a clean LC UPC simplex fiber assembly to connect the receiver to the Extend module. Ensure protective caps are in place for unused fiber ports. Want to learn more about how to clean the LC UPC simplex on the fiber assembly? Please refer to the HUBER and SUHNER LC cleaning instruction video on our YouTube channel. Connect the FO input of the GPS-over-Fiber RX to the FO output port of a receiver or the front panel of a 16-2 port module. During installation, be sure to avoid tight bends directly from the base of the fiber optic cable. To be precise, avoid a bending radius of less than 1 inch or 25 millimeters. Also, to avoid serious eye injury, do not look directly into the fiber optic ports or fiber optic connector when power is on, or when one part of the cable is connected to a module. Finally, connect the power plug of the power supply to the GPS-over-Fiber module on the back panel and to the power source. We covered the basic installation steps as well as options on how to expand the signal. Now, let's take a look at some use cases, or how the system could look like in the field. There are multiple use cases and multiple ways to distribute the direct GPS-over-Fiber system. The following 3 use cases are common examples of distributing the GPS signal to multiple cellular base stations utilizing fiber and/or RF connections. The first use case example is of a switch room application topology, which is typically part of a central office building that houses switching mechanisms and associated apparatuses. The second example is an enterprise distributed antenna system, or DAS application topology. A DAS solution extends a telecommunications carrier's network throughout the building through a series of nodes connected to in-building infrastructure to ensure network coverage is not interrupted and signal strength is maintained. And the third use case is showing an example of providing a GPS signal to a primary timing source within a switch room. A primary timing source synchronizes all participating devices and ensures time accuracy in networks under ideal conditions. All the use case examples, it is important to note the connection between the receiver and the antenna must be the QODC12 cable assembly. Additional module connections can use existing fiber infrastructure if necessary. Always maintain proper care and handling of equipment to ensure RF runs are kept at a minimum. If you have any questions regarding the multiple applications, please contact HUBER and SUHNER. Lesson 8. Troubleshooting. With any installation, we recognize there may be a need for troubleshooting, which is why we prepared the following common troubleshooting measures. If there is no power LED light, make sure the power supply is connected. If a DC-DC converter module is used to power up the receiver, then make sure its power supply is also working. Ensure the fuse of all modules are functional. If not, replace according to the specifications listed in the installation manual. And finally, check that the power switch is in the on position. If neither Link On and Laser On LEDs have been activated, then check that the fiber connection is properly installed at both the antenna and the indoor unit. Measure the voltage level at the antenna by connecting a multimeter to the troubleshooting ports 1 and 2 at the bottom of the antenna and measure voltage. If voltage level result is less than 1.7, then cleaning of all optical interfaces is needed. If less than 1, please contact your HUBER and SUHNER representative. If cleaning is needed, we recommend using a one-click cleaning tool as shown in this video. Begin by removing the end cap from the cleaning tool and place the cleaning adapter for the socket connector on the end of the device. Remove the protective cap from the socket connector. Place the cleaning tool adapter into connector, rotate and align, then press until there is a snug fit. Push base of cleaning tool toward the connector until an audible click is heard. Repeat. Finally, connect the socket connector to the plug or put the protective cap in place. Repeat all steps for the plug connector. And that concludes our direct GPS over fiber system installation video. Thank you for your time and attention today. Should you have any questions, please don't hesitate to contact your HUBER and SUHNER representative.